Here's my Mastery 4 assignment. First topic I'm going to talk about are some vectors. Vectors are essentially just the form of a parametric equation where you're given a parameter and then an x, y, or an x, y, z for any n-dimensional space. Vectors can represent position, velocity, acceleration, and they're all essentially, they can be thought of like position being the original function, velocity being the first derivative, and acceleration being the second derivative. First problem we're going to look at is to determine the position vector given the acceleration vector, the complete acceleration, velocity at 0, and then the position at 0. First thing we're going to do is integrate. So this is essentially saying the second derivative of the position. We're going to integrate our acceleration function. And because when we're done integrating, we integrate both components here. We'd integrate square root of 2e and this t plus 1. We'd integrate them both separately. And then we'd set t equal to 0 because we know our velocity at 0, and we'd solve for that constant of integration, the plus c. Giving us this over here. And then because velocity is the first derivative of the position, we can get our position by integrating our velocity and again setting t equal to 0, and then the x component, the first component, equal to -1, and the second component equal to -5. And after integrating that and solving for the constant, we're left with our answer right here. Second topic, finding the second derivative of dy dx. First thing, it is not the second derivative of y over the second derivative of x. I'm looking at dy dx because there's a division here. It's a division rule. Also, there's a chain rule in here. So we can see over here, this is kind of our basic formula after solving the chain rule and division rule here, of the first derivative of x times the second derivative of y minus the second derivative of x minus times second derivative of y all over x prime cubed. Now the cubed happened, so we had to pull out a dx when we did chain rule of saying d dt of dy dx. So that's where we get this extra x prime down here. Now let's put this to use with our problem. Find d2y over dx2 of the vector et cosine of t. This being x and this being y. So here we can say division rule, because it'd be y over x, so we can say low derivative of high minus high derivative of low all over low with an extra low, I guess, to make it e to the t cubed. Then doing some algebra and simplifying it all down, we get our final answer down here. This was all pretty simple.